right. Hi, Eli. So I'm just going to go over these two questions really quickly. With questions like this, because you're making conjectures, a lot of times the answers are kind of open-ended. Because different people might pick out different things that they notice about the patterns that they would see. With this specific one, so the first question you asked me here was number 2. And it says to examine the number pattern, make a conjecture about the pattern, and how do you know if your conjecture is valid? So if we look at the chart that we have here, we start out with a number and then we're given the number of divisors, so like how many numbers can go into it or be divided into it, and then what those two or more divisors are. So this is all kind of like, kind of closely related, and then you'll notice that the next 2 columns are a little more obscure. So it's like, what happens if we multiply those 2 divisors together? What do we get as a product? And then what happens if we take the number, so x, raise it to the power of how many divisors there are, n, and then after we've done that, we square root the value. What's the number we get? So you can see that these are 2 kind of very different relationships between the numbers compared to just like, what's a number, what's the numbers that go into it. All of a sudden we have these kind of more obscure math, like why did we suddenly decide to multiply these numbers together and then raise them to the power of the number of divisors and square root them? So usually in a question like this, if you have something that seems like you're kind of like, well, why are they doing these 2 things? That might be where you're going to start looking for a pattern. And so with these 2 here, you can notice, because like what I did when I first looked through here was like, okay, well, we just have numbers ascending by 1. If you look at the number of divisors, there's not a discernible pattern. It goes 2, 2, 3. So maybe if this would have been a 3, then you might have assumed it would keep going up. But it doesn't, right? It goes back down to 2, so no real pattern there. Same thing with the divisors. It's like 1 and 2, 1 and 3, but then all of a sudden it's 1, 2, and 4. So not a good pattern there either. But if we look at these 2 odd columns that I mentioned there, you have an obvious pattern here. Each one is equal to the same value. So the product and the square root of the power. Here we have 2 and 2, 3 and 3, 8 and 8, 5 and 5. So that's the only pattern we can see here that's consistent for all of them, is that these 2 values are going to be equal. And so that's where I would start with my conjecture. So basically for my conjecture, I would say something like, the product of the divisors of a number is equal to that number raised to the power of the number of divisors there are, square rooted. Okay, so basically we're saying the product here is equal to the number raised to the power, which is the number of divisors, square rooted. Now, unfortunately, that's quite awkward to kind of word. But essentially, if you wrote something like that, I would understand, because the other thing you would follow up on then is like it asks you to prove how can you determine if your conjecture is valid. And so that's where here I went ahead and, because this chart only goes up to 5, so I did the next 3 numbers, right? Figured out how many divisors there were, figured out what the divisors were, multiplied them out, and then did the that number raised to the exponent of how many divisors there are, and then square rooted that. And you can see that the pattern continues because we have 36 and 36, 7 and 7, 64 and 64. Now, it also asks how can you determine if your conjecture is valid? So one of the ways is to keep testing, but usually what I would do is, because sometimes if you're like within a small group of numbers, a pattern will hold, but then if you start extending much further past, you won't see that pattern holding. So just to be safe, I did a couple of extra ones. I jumped from 8 to 12 and figured out the same values, and you can see that the pattern holds. And then I jumped again to 20, and again we have these 2 numbers being equal, so the pattern still holds. So basically what I would probably say here is like after a few trials, it appears that the conjecture is valid. Like I haven't found any counterexamples, but you know, that doesn't mean that there isn't one, but it appears that it is valid. Okay. So basically that's what I would do for that one. And then the next one was number 4. Let me just pull that up here a second. So number 4 says prime numbers sometimes occur as prime pairs that have a difference of 2. So prime numbers, like it says here, is a whole number that's greater than 1 and is divisible only by 1 in itself. So basically we have 5 and 7, right? They're 2 apart and they're prime numbers. Then we have 41 and 43, and it says there is at least one prime pair between 1 and 50, 51 and 100, 101 and 150. Make a conjecture about prime pairs. Is your conjecture valid? So basically what I did with this one was, again, usually if you want to form a conjecture, you need to try and gather, you know, a reasonably good amount of evidence. So essentially what I did here was I just pulled up a list of prime numbers because I didn't really want to waste my time trying to think of them all. So I pulled up a list of prime numbers, which is easy to do if you just Google like prime numbers from 1 to 500 or whatever. And then I started grouping them, right? So if I look at 1 to 50, I have 4 pairs. 51 to 100, I have 2 pairs. Now if I jump to the section between 100 and 200, or 101, I guess, and 200, it's a little bit odd because we have 3 pairs under like 150. This one is right on that border that they had suggested in the question of like 50 to 51. So 149 to 151, it's on both sides of it. And then on the upper end, we have 3 more pairs. Then if I go to between 200 and 300, I have, let's see, 2 pairs under 50, 2 pairs over 50. If I go from 300 to 400, I have 2 pairs under 50, but nothing over 50. So no over 50. And then same thing here. If I go, sorry, I'm running out of space here. So then if I go 400 to 500, I have no under 50. Right, I only have 461 and 463. And then if I go 501 to 600, I have 1 of each. So we need to think about what would be the pattern that we can actually state here, because at first it seemed like to me when I was doing this, I'm just going to get rid of this question actually a second so I have more space on the camera. So to me at first it seemed like when I was doing this, I thought, okay, well there's like 6 total pairs here, then 7 pairs, then 4 pair, 2 pair, 1 pair. So I thought maybe the number of pairs maxes in the 100 to 200 range, and then it starts dropping off over that. But in order to see if that was accurate, because I was down to 1 pair here, I thought I better do 1 more segment and see if that's accurate. And then we see that it starts going up again, right? 2 pair. So I can't say that conjecture that it increases up to a maximum number of pairs at 100 to 200 and then decreases. So really the only conjecture I can make about this at this point that is an actual thing that's accurate for all of these segments is that between like segments of 100, so like 0 to 100, 100 to 200, 200 to 300, 300 to 400, 400 to 500, 500 to 600. So between segments of 100, there is always at least 1 pair of prime numbers that are separated by a difference of 2. And that's the only thing I can say, right? Because for this one, I can't even say that that would be true for like 1 to 50, 50 to 100, 150 to, or 101 to 150, 150 to 200, because it doesn't hold true for these two here. For this one, there's nothing over 50, nothing under 50. So what I would do is expand what I'm talking about and say for every set of numbers between, like as a grouping of 100, there's always going to be 1 pair of prime numbers that have a difference of 2. Now let me just have a look here at, It says make the conjecture, so that's the conjecture I'm making, and then it says, is your conjecture valid? And I would say like, yes, probably, because I've done like quite a few pairs, right? I mean, there's only so much you can do in a certain amount of time, right? So I would say it seems like the conjecture is true for groupings of numbers between the groups of numbers of 100. Okay, so just be aware too, like I think one of the stressors with these kind of questions is the fact that it's kind of open-ended. Like you can always think like, well, maybe it won't be true somewhere, you know, at like in the billions or who knows what. So sometimes the best we can do is just say it appears based on, you know, a good amount of evidence that this conjecture will be valid. Okay, so that's everything, and I hope that helps you.